Right. So an airline charges the following baggage fees: 25 for the first bag, 35 for the second, and suppose 54% of passengers have no checked luggage, 34% have only one piece of checked luggage, and 12% have two pieces. We suppose a negligible portion of people check more than two bags. The average baggage related revenue per passenger is. So we're looking for basically the expected value. So what you're doing was right. You want to use the one variable statistics by putting the data into the lists. The important thing here is to figure out what the possible values are. This is where the trick comes in. So if I do stat, edit, clear my lists out. So let's see here. An airline charges the following: 25 for the first bag. So some people won't check a bag. So that's going to be one outcome, 0. Now, if they check one bag, they're paying $25. So that'll be another outcome. Now, here's where it's a little confusing. If they pay $35, this is not really obvious from the wording of the question, but they're paying $35 for the second bag on top of the $25 for the first bag. So the people that are checking two bags are really paying $60. That might be where the confusion lies. It's a little misleading here. It looks like they're paying 35 for both bags, but it's 25 for the first and then 35 for the second. So they're paying 60 for both bags. All right, so what percent of passengers have no checked luggage? So 54% or 0.54 will pay zero fees. 34% have one checked, so that'll be 0.34. And 12% will pay the $60. Okay, so now when we do that, we'll go back to stat, calculate one variable statistics, L1 and frequency. So we get the average fee is going to be 15.7. Judging by this, I think that's what the issue was. Standard deviation will be 19.95. And then it says about how much revenue should the airline expect for a flight of 120 passengers. If this is the average baggage related revenue, we just expect that 1570 times 1570 times 120 passengers, 1,884.